Hi everyone, in this video we are going to see one more problem. The problem name is search insert position and the problem number is 35. Alright, so first of all in this video we're going to understand this problem. We're going to clearly understand what this problem says. After that we're going to move to the logic part where we are going to see how we can solve this particular problem. And after that we're going to move to the implementation part where we are going to implement our logic in C++, Java and Python programming language. And guys, if you want to see the implementation part in your programming language only, then you can move to that particular part. I have mentioned the timeline as well. Now let's move to this problem and see what this problem says. Given a sorted array of distinct integer and a target value. All right. Now return the index if the target is found. If target is not found, then return the index where it would be if it were inserted in the order. So guys, we are given with a num array. So here you can see in example one, we are given an array. So let me write an array 1, 3, 5, and 6. All right. And we are given it one target as well. So here target is nothing but 5. So let me write target is equal to 5. Fine. Now guys, let me write an index as well. So this is 0 index, 1, 2, and 3, right? So now we have to do what? We have to check first of all this target, whether it is present in this array or not. So here you can see 5 is present, right? So now we have to return what? We have to return the index of that particular value. So here you can see 5 is present at second index, so we are going to return 2. And in the output as well, you can see that we got 2, right? Now guys, this was the problem when we have a target in our array, right? And they also told that if target is not present, then you have to return something there as well. So here in second example, you can see that if I write here target is equal to 2. So now you can see 2 is not present, right? 2 is not present in this array. So what you can do? You have to return that index where if 2 was inserted in this array, then where it will be, right? So if I have to return that index here, if I have inserted 2 inside of this array and that array is still in sorted order, then what will be the index of that particular 2? So see guys, I have to return here 1. And why? You can see if I insert 2 in this array, so I have to insert after 1 and before 3, right? Then only sorted order will be maintained. It's not like that I can insert 2 after 3 because it will not be in sorted order then. I can't insert 2 before 1 as well, right? It will not be in sorted order. I have to insert between 1 and 3. Then only we can say this is in sorted order. I hope this much makes sense. Okay, so if I insert between 1 and 3, that means I have to insert at first index, right? So let me maintain this. Here is now gonna be 1, 2, 3, and 5 and 6, right? So now you can see that the index is nothing but this is 0, this is 1. So 2 is stand at 1 index. So we are gonna return 1. And guys, we don't need to do this much hard work. We don't need to insert it. We don't need to check it. We are gonna do by just a one algorithm that gonna solve our all the problem. But you need to know what is this problem, what this actually says, and how you can do in a brute force as well. Because interviewer always want that first of all you should come up with a brute force approach, right? So all right, now this was the problem. I hope now you understood. Now let's move to the logic part, see how we can solve this particular problem. So let me move below. So let me scroll it. All right, now guys, I'm going to take a one example. So let me add first of all a logic, and I'm going to take one example that is our array is nothing but let's say 1, let's say 3 and 5, and let's say 6 and 8 and 12. So this is our array. I hope this much makes sense. This is an array of 6 size. Fine. Now first time let's take a target. So my target is nothing but 5, or let's say target is 6. Let's make it a simple, right? So my target is 6. Now guys, can you tell me, they also told one thing that is nothing but you remember you must write an algorithm with big of log of n runtime complexity. We can't solve in big of n, right? So I have to written here something that we can't solve in big of n. We have to solve in big of log of n. Now tell me is one thing, whenever we need to search something from a search space, which algorithm is the best? If that particular search space in sorted order, or we can say in any order, but it should be in ordered, right? So you will definitely say binary search, right? Binary search is an algorithm whenever our array is in order. If our array is in order, that means it may be in sorted order, it may be in we can say increasing order, ascending order, descending order, it may be in decreasing order, right? So if our array is in order, then we can say that our binary search is the best algorithm which can do our tasks in big of log of n, right? So same here we are going to use a binary search algorithm because our array is in sorted order. So we can use a binary search algorithm which is going to search our value in big of log of n. So let's do a binary search. If you don't know about binary search, don't worry, you're going to learn everything in this video. So I'm going to just write here binary search. Let me write here, remove all these things, and just write here binary search. This is already written, right? So what I'm going to do, I'm going to just write a little code. That will not be a much code, just a little code so that you can understand binary search better, right? So here, first of all, by default, our low is going to be nothing but 0. Low is tell us that the search space is starting from, right? So it is starting from 0 index, right? That is definitely going to start from 0, right? Array will have at least one value inside of this problem, right? And high is nothing but guys, the last index value. So here you can see this is 0. Let me write here 0. This is 1, this is 2, this is 3, this is 4, and this is 5. So this is nothing but 5. So basically this is length minus 1, right? We can say if the data are 6, that means the height is going to be 6 minus 1. I hope this much is clear to you. If data are 6, that means number of elements are 6, then we can say height is going to be 6 minus 1, that is 5. Fine. Now guys, what we can do, we can say we are going to write our we can say binary search algorithm, that is nothing but we can say while low is less than high or equal to high. So while our low is less than or equal to high, that means we have to, we can say our search space exists, isn't it? Because 0 to 5, that means search space exists. If I say 7 to 5, that means search space does not exist, right? All right. So this is our code. Now guys, we are going to do something. We are going to say find out a mid. And why mid? Mid is nothing but low plus high divided by 2. All right. So this means also divided by 2. If I do nothing but like this as well, so this means also divided by 2. But it may go somewhere integer overflow, right? All right, so this is what we have done. We have find a mid. Now once we have find a mid, let me mention here low is initially here, high is initially here, right? Now mid will be nothing but 0 plus 5 divided by 2. That is nothing but 0 plus 5 divided by 2. It is nothing but 2, right? Because we are taking an integer value, not a float value. So it will become here mid here. Now we have to check just two conditions, or let's say three conditions. First is if mid value is equal to your target, then you have to do something, right? All right, and if second condition is nothing but if mid value is greater than your target, means whatever the value present at mid index, it is greater than your target, then you have to do something. And the last third condition is if mid value is less than your target. So this is simple, a binary search algorithm. I hope now you clear with this binary search algorithm. If mid value is greater than your target, then you have to do something. If less than your target, then you have to do something. If it is equal to target, then also you have to do something. So now here you can see mid value is nothing but 5, right? So mid was nothing but our we can say 2. So on 2 we have 5, but our target is 6. So here which condition satisfied? Is the we can say third condition satisfied, because it says that mid value should, if it is mid value is less than target, that means 5 is less than target. So we have to do nothing but we have to increase our low. So we can say low is going to be increased. So low is nothing but it is should be equal to mid plus 1. So now low will come mid plus 1, that is nothing but here. I hope this makes sense. Fine. Now we are low is nothing but mid plus 1, that means 2 plus 1 3. Fine. Now again find a mid, because this loop will continue because 3 is less than or equal to 5. So now 3 plus 5 is nothing but 8. So we can say 3 plus 5 is nothing but 8. 8 divided by 2 is nothing but 4. So now mid is 4. So mid will come here, right? So mid, the value at mid is nothing but 8. So we can say if 8 is greater than, check out which condition satisfied. Here you can see that the second condition satisfied. Here we can say mid value is greater than 8. Means mid value is greater than target, right? So here 8 is greater than target. Yes, 8 is greater than 6. So we are going to do something nothing but high should be equal to mid minus 1. Now we have to move this high value, and we are going to say this should be mid minus 1. That is nothing but here only, right? Mid minus 1, that means 4 minus 1, that is 3, right? So height will become equal to 3. Fine. Now you can see that still this condition satisfied while low less than equal to high, because 3 is equal to we can say high, right? So still this gonna work. So again we are going to find mid. Mid will be 3 plus 3 divided by 2. That is nothing but 3 only, right? So now on 3 index we have 6. So here you can see first condition satisfied. Mid value is equal to target. So just we have to return nothing but mid. We can say that we found our target value which is present at that mid index. So return 3. So we have written mid. So now you can see we have solved this particular problem only when we are sure that our data is present inside of an array. If data is present inside of an array, then this particular binary search algorithm will gonna work efficiently, right? But they have given a little bit problem, right? They have told that if data is not present, then you have to return the index where it will be inserted in the order. So now guys, if you little focus over, I have to just change one thing. I'm changing here the target nothing but 7. Now you guys can see that 7 is not present in this array, right? 7 is not present in this array. So what we can do, we can say we have to return but an index where if I insert 7 in this array, then it should be that index should be of the 7 index, 7 particular value, right? If I insert 7 inside of this array, then that index should be the index of this 7 value, right? So here you can see you can insert 7 between 6 to 8. So we don't need to do check anything. We just say that keep running this algorithm. Again, I am doing the same algorithm. I'm going to say low is nothing but here. So I'm saying that low is here, high is here. So again, low is 0, high is nothing but 5. So you first time you will find a mid, that will become here, right? 2, mid will be 2. So we are going to say 5 is greater than 7 or less than. It is less than 7. So third condition will satisfy. Low will come here, mid plus 1, right? Again, if low is 3 and mid is high, then mid is going to be 4. Mid come here. Again, you can see 8. It is greater than 7, right? So now you can do one thing. whenever you find a value greater than 7, you have to check one thing. Whenever you come to this particular second condition, you have to check one thing. You have to check one thing, that is, check if mid minus 1 value, if the last index value, mid minus 1 value is less than target, then you have to return mid. I hope this makes sense. If my mid value is greater than target, if it is greater than 7, then you have to check the last value. If that last value is less than this target, that means I'm standing on that particular value, which where I can insert 7. So here you can see 8. 8 is greater than 7, but the last value is nothing but 6. If this is smaller than 7, that means I have to insert 8, this 7 at this 8 position. So I'm going to return the index of 8, nothing but return the index of 8. So I'm going to return mid. But if it is not the case, then you can return nothing but not you have to return, you have to just decrement your high. You can say high is nothing but mid minus 1. I know this code is become a little complex, but I believe you understanding it. If the value is not present, then you have to do one thing. You have to check if the mid value if is greater than target, then check the last value. If it is smaller than target, that means the target will never present, right? Because I am standing at a position where the target value is we can say smaller than, right? But the last index value is greater than. So here you can see I'm standing at 8, which is smaller than which is greater than target, and the last index value is greater than target. Last index value which is greater than which where target is greater than, right? Here target is smaller, here target is greater. That means I can't find any index where our value is going to be equal to the target, right? I hope this much is clear to you. It is a little complex because you're learning a lot of things in a single video, right? You first need to understand the binary search, then you have to move to this particular problem. All right, so I believe now you understood this. We have to just write one condition in the if statement, that is nothing but if mid minus 1 is smaller than target and the current mid is greater than target, then you can do nothing but you can return the mid, because we can insert that particular value, the target value, on the place of our mid. Now, once we have done this, we are gonna see the implementation part. I hope this was the logic. Simple, this was the logic. Here you can see 8. So we can say 8 is nothing but greater than target. So the last value is smaller than, then return this mid value, that is nothing but 4. So in this 7 value, we are going to return 4. So whenever we are given the 7 in this array, we are going to return 4. All right. So now let's move to the implementation part and see how we can solve this particular problem. So first of all, I'm going to do with the Python programming language. So let's move to the implementation part. And here, guys, let me see the size. All right. This is enough size, 125%. So let guys, so I am with the Python programming language. Here, what I'm going to do, first of all, what I'm going to do, I'm going to say, check out the first thing, that is length, right? So n is equal to length of nums. All right. And here I'm going to say one thing, the base condition, if nums of 0 means the first index value is greater than our target, or we can say it is greater than target, that means the target value here we can set on the 0 index, right? The one base more condition, that is if nums of n minus 1, or we can say n minus 1 is smaller than target, if the last index value, if the last value of an array is also smaller than target, then we can say target is greater than the last index value, right? So we can return the last one, return n. But if it's not the case, then we are going to do one thing. We are going to say low is going to be 0, high is going to be n minus 1. While low is less than high or equal to high, we have to mention the equal as well. So we mention equal. We are going to check one thing, that is mid. Mid is going to be low plus equal to high and divided by 1, divided by 2, right? And divided by 2 is also equal to, we can say right shift of 1, right? All right. So now once we are done with this thing, what we are going to do? We are going to do one more thing. We are going to check if nums of mid is equal to target. If it is equal to target, then what we can do? We can say return that particular mid. But if it's not equal to target, then we are going to move to the second condition, that is if nums of mid is greater than target. Let me write nums. If nums of mid is greater than target, then what we can do? We can do one thing. We have to check the last index value, right? I have told you that. Let me do something. I'm going to say if check if nums of mid minus 1, nums of mid minus 1 is smaller than target, that means target will never present in this array. Then we can say return mid. But if it's not the case, then you can say high is going to be mid minus 1. And in the last condition is nothing but if nums of mid is less than target, then simply you have to do nothing but you have to say low is going to be mid plus 1. And simply by this, I believe you must understood that what we have done. By this, we have completed our implementation. Let's try to run this code and see whether we are getting output or not. Okay, I got an error because I have to use a nums, not num. And let's find out whether I have any more error or not. You can see that, guys, all the tests are passed. So let's try to submit this code. And here we go, guys. It's successfully submitted, right? So we have successfully submitted Python code. Now let's move to the C++ code. So I'm going to write here C++. And inside of C++ also we don't need to do anything. We just need to find first of all length. So I'm going to say int length n is equal to nums dot size. And after that, what I'm going to do? I'm going to check the base condition if nums of 0 is greater than target, then guys what we can do, we can say return 0. And one more condition, if nums of n minus 1 is less than target, then we can say return n, right, because we have to insert on that n index. Now if both the base condition are not satisfied, then we are going to move to binary search. So binary search, we are going to say int low is going to be equal to 0, and high is going to be equal to n minus 1, and while low is less than high, so we can do one thing, we can find a mid that is going to be low plus high and divided by 2. And once we are done with this, we are going to say, let me write a semicolon as well. So we're going to check the three conditions as I have already told you. If nums of mid is equal to target, then we are going to return nothing but mid. But if it is not the case, then move to the second condition. If nums of mid is greater than target, then what we are going to do, we are going to check the last index as well. If nums of mid minus 1, let me write mid minus 1 is less than target, that means target will never present, so return mid. If it is not the case, then move your high is equal to mid minus 1. And the last condition is going to be if nums of mid is less than target, then you can say not return. You have to do one thing, that is low is going to be mid plus 1. We are going to move to our low, right? Once we are done with this, we are solved our implementation. But in C++, what we have to do, we have to return something, right? We can't leave it. So by the purpose means by just avoiding this error, I can just return a high, right? So I'm returning a high. Let me write high. And here I'm just mentioning also that just for avoiding error, right? Now let's try to run this code. I'm sure that definitely this while loop. Okay, I got an error, but again I got the same error nums. I have to write nums. Why I'm keep writing num, right? And guys, what I'm saying that in while loop, I'm definitely sure that my answer will get submitted, right? So here I have to use a semicolon. Okay, now let's try to run this code. I got two errors in C++. You have attempted code to run. Okay, I think I need to take a premium. Well, let's so you can see that all the test cases are passed. Let's try to submit this code. And here we go, guys, right? Now let's move to the Java implementation. So I'm going to write Java, and here guys I'm going to do same thing. I'm going to say int let me write this int n is equal to nums dot length. Okay, after that, once we are done, we are going to check a base condition. If nums of 0 is greater than target, then we have to return 0. And if nums of, I remember here I need to write nums. So if nums of n minus 1 is greater than target, no, it is less than target, right? Then only we can say return n, because the last index is the we can say the smaller index, right? Fine. Once we are done with this thing, what we are going to do, we are going to say, all right, so what we are going to do, we are going to implement our minus as same. So we can say int low is going to be nothing but 0, int high is nothing but going to be, at high is going to be n minus 1, and we're going to say while low is less than or equal to high, keep going. And here find out mid. So mid is going to be low plus high. So let me write plus, not minus. Okay, now we are going to divide by 2. Once we found a mid, we are going to check three conditions. First is if nums of mid is equal to target. If it is equal to target, then we can say return mid. But if nums of mid is not equal to target, let me give it a space. If it is not equal to target, if it is greater than target, that means we have to check one condition. Nums of mid minus 1 is let me write mid minus 1. That is it is less than target. That means mid target will never present. So we can say return mid. But if it is not the case, then you can say move your high to mid minus 1. And one more condition, the last condition, if nums of mid is less than target, that means we are standing at the value which is less than target, then we can say move to the high particular position, right? So we can say low is going to equal to mid plus 1. We incremented our low to mid plus 1, right? So once we are done, we have to return something as well in Java programming language as well. So Java says you can't return if you have given the data type int, so you have to return something. So I'm going to return high, and again I'm going to say let me write his semicolon this time, and here I'm going to say for avoiding error, right? Because I'm sure that definitely in while loop I'm going to give my answer to this particular function, right? But still, for avoiding the error, I'm just writing here return high. Now let's try to run this code, and you can see all the test cases are passed. Now let's try to submit this code, and it got submitted, right? So by this we have submitted our code in C++, Java, and Python programming language. I hope you understood this problem as well. I hope you understood the logic as well. If you learn something new if you learn something new in this video, don't forget to hit the like button and subscribe my channel. Meet in the next video.